arc length. The arc length. We're going to find the arc length. Okay, find the length of the arc on a circle, and it has this radius r. Oh, yeah. Like, I think you're right, Kella. It has that in the... And if you look back in the examples, it has a little formula for you guys. Okay, intercepted by the central angle. So let's just draw a picture. Yeah, let's draw a picture. Shall I do 85? Yeah, let's do 85 because that one looks really complicated. Did I say 83? Yes. Okay, I'll do 83 then. Okay, we'll do 83. This one's in degrees, and then I'll do 85 because that one's in radians. All right, so if you had a radius of 15 inches and you had a central angle of 180 degrees, how would you find the arc length of that? Man, my brain's going everywhere. Do you guys know how to find the perimeter of a circle, the circumference of a circle? It's 2 pi r, right? Okay. That would give you the length all the way around. You know, if this was 15, you would just have to plug that 15 into that, and then you would find it. Correct? Correct. But that would be the whole thing. But we don't want the whole thing. Our angle is only 180 degrees. So what we're looking for is this length right here. That's what we're looking for. So you would just have to half that. All right. Now, this is what I think, though. When I think of arc length, I think, okay, what fraction of the circle is wanted? 180 degrees out of what? Oh, what's the total? 360? And you guys already knew this. That's actually just 1/2, right? Like 180 is half. So half of the arc length, like the total arc length, is what we want. So we want half of the total arc length. And how do we find the total arc length? We find the circumference. We go 2 pi r. So we go 2 times pi times, what's my r? 15 inches. All right, so that would be 30 pi. And what is half of 30? That's your arc length. Don't forget your label. Gotta put inches on this guy. Okay, I said I would do 85. Now I'm going to do it. Okay, so our radius is 3 meters. Now we're imagining this circle, right? And this is standard position, and we need 1 radian. Okay, you guys know that this is 3.14 radians, right? It's pi. So what would 1 radian look like? Kind of like that, maybe? So that's 1 radian? How about rad. And then my radius is 3 meters. So I'm going to multiply. What's my fraction? If it's, okay, over here we got 180 degrees. And so we knew that was over 360 because that would be the total, right? So we got our fraction by doing that. But this is in radians. What's my fraction? What fraction of the circle do we want? What fraction of the circumference? It would be 1 radian over what? Yeah, 2 pi. Because 2 pi radians would take us all the way around, right? I'm not going to write 6.28 because that's actually a rounded number. It's not exact. I want to stay exact, so I'm going to have a pi involved. And so I'm going to take that, and I'm going to multiply this by the total circumference of the circle, so I can only get a fraction of it. So that would be 2 times pi r, and so we got pi, and then my r is 3. Don't forget it's in meters. And so we get down with this. We go, we put that over 1 so I can see that I can cancel out these, cross-cancel the 2 pi's. And we're just left with 3 meters. That's your answer. Say it again.
Isn't the radius 1 radian? So wouldn't it just be, wait.
Yeah, no, you're right. Okay, so like you guys learned that 1 radian, so like if this was 3, then the radian would be, this length right here would be 3, right? And this would be 3. You guys remember?
And then angles are equal.
Yeah, so like if you just have 1 radian, then you just, yeah. So if you really understand radians, you didn't even have to do my stupid formula and figuring it out.